start this up.
Here's my file here. So as far as the seniors' requirements, is there to give a presentation, you know, of their project, to give you guys some ideas and inspiration. So go for it, Tom.
Yeah. We used to have crates for open house. We had crates that are going to catch these. Now they're just going to fall on the ground. I don't really care. But empties are going to go over here. The fulls are going to go there. Half full is here. And then empties are going to go over here. Now when the empties hit this sensor, proximity sensor, the robot is going to come around and pick it up. Now, and we'll drop it in this bin, and that's controlled by its own PLC. This has been a little touchy at times, so every now and then the gripper won't actually close, but it's doing alright right now. And then this is controlled by its own PLC. I don't know if you guys know what PLCs are. It's your first semester, right?
Yeah, we did some Logic Pro already.
Yeah?
Yep.
Oh, okay, cool. So you kind of know what Logic looks like then. Basically, you have a bottle for it. Stack it on the cube, push it through, and what's controlling it is this PLC. This controls our capacitive sensors, which instead of sensing the plastic, they sense the center where the water is. So that's how you sense how much water is in it. So, depending where you place them, that's why this is low. It senses if there's any water at all, and this guy senses there's water at the top. And that way you can tell if they're full, half full, or empty. And this PLC basically is what's controlling everything. And the most, I have those going to these relays right now. So when you do this, you'll see that light comes on, and this light will come on to close it. And the same for the other relay. You can actually watch the code running live from this computer screen.
Yeah, come over here, guys.
So here's the ladder logic code, and I guess the best option to show right now is this timer, which simply controls the pin, and that resets itself every time. And then that controls when the bottle's released. So I give myself 6 seconds to let a bottle, before a bottle goes through, and then it's open for 650 milliseconds, and that's just enough time to let one bottle through, but then to keep the rest back. And that's kind of how I keep one at a time so that we don't overpopulate the system.
Yep, great.
And that's my bottle sorter.
Yep. Now the robot you've actually interfaced directly, right? So
that has its own PLC. So
right. Normally these come with their own controller, but these guys bypassed the robot controller and made their own interface with your own PLC. Yeah.
Instead of having a convenient controller, we had to take the wires and learn what they did and rig it up ourselves. So you can see this is where we have everything wired up to. And we had to use shorts in order to hold the robot's arm in place when it's not being used. And sometimes it gives us issues, but it's been pretty good overall. And that's going for nothing. So we just had wires and we made this work.
Yeah, I think, didn't we talk about maybe that the gripper motor was getting hot?
It might, yeah. And,
like right now it's pretty cool.
I think because it's shorted out that might happen. We're not totally sure. We've tried to fix it since open house.
Yeah.
There we go.
It didn't open.
So,
yeah, and the motor's not hot. So yeah, it must be something else.
We think it's a wiring issue. This, all we did was move it an inch, and that's what threw it off. It was working 100%. Then that wire. So we think there might be a wiring issue within here.
Yeah.
So every now and then it's touching, other times it's not. So it's like the ultimate intermittent issue.
Yeah, yeah, those are tough ones to figure out. Yeah.
And then all the conveyor belts are controlled from in here. This is where we have our VFDs, which are variable frequency drives. So you can see we're using like 60 hertz, 45 hertz, and each of the 10 belts have their own VFD attached to them.
And that gives you speed control, basically?
Speed control, directional control, and then you can even control how fast they accelerate and decelerate when they're turned on and off.
Now, is that better energy efficiency also, as opposed to a motor that's just all on, all off, I would take it?
I would think so. I'm not totally sure, though. I'd have to look into that.
And generally, you don't like motors to turn on and jerk on and then come to a complete stop. It's better to ramp them up for mechanical reasons, you don't want to stress your components too much. So it's better to have a gradual on and a gradual off, I'm sure. So.
Yeah, so controlling the acceleration is definitely one of the best parts of the DFDs.
Yep.
That's my project.
Now, how did you pick this project? How did that work? Was it, maybe you guys, let these guys know about what's the process to pick your project? Is it your choice, or is it?
Yeah, it's completely your choice, because I'm in semester 7 right now, and since I've been through so many different classes and tried so many different projects, you kind of get a taste of what you enjoy. So your senior project is kind of what you want to do and what you want people to, notice you for. So, you might present this at open house and an employer will come by and be like, wow, that's a really impressive project, I want to hire you. And we've had that happen here. So people have actually come in looking for people, and they've hired them basically on the spot just because their project was so impressive. Right. So you pick what you are interested in, and then you definitely want to be interested because you'll be working on that for 2 semesters basically. And I'm kind of ahead just because I had to do this for robotics class. So I was doing this for open house on the 26th of this semester. But I mean, it doesn't have to actually be 100% done until May of next semester. So I'm going to do a lot of work on this. This has to be changed a lot. This is not my final, it's just my open house project. But, it gives you a taste of what it's basically going to be doing and how it works. Because the conveyor belt system is kind of my foundation to all the bits I'm going to add to it.
Yeah, cool. Can you name off some of the other projects the students are working on for their senior projects?
I know we had that inverted pendulum that Matt's working on, which is going to be using like PID loops to control, basically keeping a pole in the air. Yeah. So it's just a motor going back and forth with a pole attached to it. Right. And you kind of have to like hold it up, and then when you let go, it won't let the pole fall. Right. So if it falls this way, it automatically adjusts to straighten it again. And it kind of works the same way as a Segway. Tony is actually working on a Segway. Oh yeah. So yeah, he's going to build. He's already made a smaller one. I think he's trying to make a full-size one. So he's trying to get all the equipment to make a full-size Segway that can hold a person. And for that, he needs Cayman filters and all sorts of crazy stuff. So he's been working on that pretty hard. I know Charisse is doing that micro mouse. Okay. So kind of a path-finding mouse robot that you can just kind of drop into a maze and it'll find its way out. And other senior projects. Oh geez, Phil's using those Zybo boards. Yeah. So he'll be learning how to, it's a lot of DSP. I forget the main point of his project, but he's kind of learning how to use it first because it's brand new. Yeah. And even Calvin West is still trying to learn it. Right. And then he's going to do some filter. So yeah, he's got a lot on his plate. Yeah. And other than that. Do you guys have any questions for Tom about? Yeah.
Yeah. How long did it take you to put all this together?
Well, the first step was mainly just tearing everything apart. Because when I got here, there was like 4 years of just people piling on more and more equipment. We even had like a box under here and wires over there and stuff. There were full boxes filled to the top with just junk that was left sitting around. So the first thing I had to do was I basically unwired everything and took everything off that wasn't like being used directly for the conveyor belt system. And I kind of broke it down to its like main components. And then once I kind of cleaned out the system, then I could start wiring what I needed. And the hardest part of that was, you can see all these wires that you have to trace. And I mean, those are going up through here and into this. So you gotta, even for this button panel and everything, you gotta trace them. A lot of them go back to here, and then other ones go into these, they feed into those. And I mean, all these wires have been traced throughout the system. So a lot of it was just, I spent most of my time learning how the system works, because there's not a whole lot of formal documentation and everything to really figure that out, and especially if you're using stuff that older students used, because as you probably know, when students hit crunch time, they just quickly start throwing things together. They're not like properly wiring everything and putting labels on them. So I had to go back and figure out how they were doing it and what their intention was. And then once I kind of did all that, then actually making the project itself wasn't too bad. I definitely put probably 100 hours into it. And, you know, that includes helping my other two partners with the robot, and then mounting these sensors and learning how to wire them up. Because whether they're a source or sync or whatever options you have to learn how to wire them up differently. So it's all based on the situation you're in. And also I had to figure out what controls what pin. So all of these control a different pin, one of these pneumatic pins, and then these control the arms. But these are all things you don't know from the start. You're just given a giant table, and it's just like, well, hey, learn how to use it, good luck. And that's basically what I did. I just spent a lot of time looking at every single part of this table and figuring out what they're all used for and getting it down like to what its purpose was. And I did a lot of documentation, a lot of wire labeling, a lot of time just tracing wires and looking up specs and just user manuals for how to actually use the stuff. So, it's definitely a lot involved, but I would easily say 100 hours just to do it properly. It's one thing to just throw together a project and just be glad it works, but not be totally sure why it's working as it is. It's another thing to fully understand your equipment, and then if you have to make a sudden change or fix it, you know exactly what's going wrong with it. So it all depends on how much effort you're willing to put into it. And by the 7th semester, you've kind of been, shaped into a good enough engineer that you're willing to put in the 100 hours. It doesn't seem like such a big deal anymore. And that was between August and October 26th. So.
Yeah. Now a lot of your documentation is in OneNote. Do you still use OneNote for your?
My personal documentation, yeah, a lot of it's in OneNote. We still use that, and then I still had all the online user manuals and everything for the equipment being used.
Right.
So you can look that up and download it.
Right. These guys have been using OneNote with OneDrive with the cloud storage, so we're trying to get them used to documenting their work, because you'll need it for other classes too, right? Use it for.
Oh yeah, I mean, anyone here who's in robotics, who's in the 4-year for electronics engineering? So, wait, who's robotics? No one. So all you guys are in the 4-year.
Yeah.
Okay. Yeah. Well, you're gonna have West, and he'll make sure they're using OneNote for everything. So you don't have to worry about not knowing how to use OneNote, because you'll be doing it for every single one of his classes, and a lot. So.
What are your job prospects now? Any? You're graduating in May, right? So.
Yeah, I'm graduating in May. I've been looking at a bunch of different places like H&M Networks, and just on November 7th I had an interview with Sam Adams, and I'm looking at places in Virginia like NAVC, and some of the other places around there, Schneider Electric. I mean, there's a bunch of opportunities, and it's kind of nice because they're not asking, like they need more people. They can't find enough people, especially good people. So it's not really a problem of me trying to find any job. It's kind of nice because I actually get the option to choose a job. So there's a lot of options out there. Luckily, you're in a major where you're not going to have to worry about, not having any options. Like you might be if you were like an English teacher or something like that. I mean, there's going to be plenty of openings out there. It just depends on like where you want to live and what you want to do for a living. So given the jobs that I want to do, I mean, that Sam Adams job was that's been going pretty well. The NAVC one down in Virginia, that's going to be me working on the electronics for the nuclear reactors and the submarines that go for months on end in the ocean. So that's what I'm mainly hoping works out, because that's the area I want to be in most. But, I mean, depending on what you're doing, there's so many options. I mean, they can't find enough people that are good at electronics. So plenty of prospects, yeah. And especially if you go to the Penn State Career Fair and the Penn College Career Fair, I mean, I've been going to a lot of interviews, let me put it that way.
Yeah, good. That's good. Now, have you done any internships while you've been here?
Mm-hmm.
Where have you worked?
Last summer I did an internship for First Quality in King of Prussia, and I don't know where you guys are all from, but King of Prussia is right outside Philly. Mm-hmm. It's in that Basque area. So I live in Warminster, PA. It's around Doylestown, if anyone knows where that is. Mm-hmm. But it took me about like an hour to drive there every day. But while I was there, I basically did all the work for the PLCs and HMIs, so I would actually be allowed to go to the main equipment, and they had this 15-acre floor with 18 giant machines that went from raw product to being finished products, fully packaged and on pallets. And I would actually be able to go to those machines, upload the code, find whatever I needed to fix or change, modify, and then go to the actual machine and upload it once it was approved by our senior engineers there. And then also the HMIs, which are the touchscreens for the PLCs. That's how the basic workers go through and change settings. They can just go to the touchscreen and simplify everything for them so that they can use it. And I would have to go there and make not only security changes, depending on what kind of worker they were, because they'd have to scan in, but also overall design changes. So if they needed a new page added or they needed this button to lead to something else, then I did a lot of work changing that. And even did stuff like I designed an electrical panel, just like this one, to control a blowout system for rejects. So if there was a product that needed to be rejected because it wasn't matching, it wasn't up to spec, then it would get blown off the line and then go through an air system. So I designed this electrical cabinet for fans that would basically, they're three-phase motors of different horsepowers that would basically have enough power to suck them through the entire plant over to this recycling facility they had.
Now, what was the product you were making there at King of Prussia?
They made there's a lot of hygienic products.
Okay.
So it's everything from like adult diapers to maxi pads and stuff like that. So
I see. And this would be like plastic and filler material that would, like say, would blow up basically.
Yeah.
And they would have to get it off the line so that it wouldn't interrupt the production, basically, right? So
yeah. So there's a lot of paper, a lot of string, a lot of plastic. You got glue. That was kind of it, but it definitely was messy. And whenever I was attached to the machine, I have a lot of different opportunities to mess things up. So I had to be had to be very careful to make sure it wasn't me that was screwing things up. And I never actually brought the lines down. So,
yeah, that's good.
It's just a matter of being careful and double checking what you do before you actually hook up to machines. Because if it's downtime, then they could lose millions. If you're down for an hour. So.
Yeah. Did you work at other companies for your internships, or was that your only one?
That was my only internship at a company like that. I mean, other than that, I had other college jobs and stuff like that over the summer and everything. Just like working as a technician at a company, taking care of their printers and make sure their computers are up to date and stuff. But the one most related to my internship, to like my major, would have been that internship at First Quality. So, I mean, you guys are just starting out. I made the mistake of not trying to get an internship early enough. So. Definitely try to get one every summer, because if you have 3 internships under your belt by the time you start looking for full-time jobs, then I mean it's going to be hard not to find a job. Really, they love to see that. So internships mean a whole lot. So if I had been smarter, I would have worked harder to get an internship at least my second summer.
Yeah, and the pay's like at least $12 an hour, right? I mean,
I got 18 an hour.
18, wow. Mm-hmm. Yeah, so it's it's helps the school tuition and everything else.
A whole lot. And I'm still running off the savings from that because I'm not working at the moment.
Yeah.
So I can't just because of how busy things are. So it's nice to have that saved up so I can kind of, have fun along with not having to work. Well, I can just focus on studies basically.
Right. You guys have any other questions for Tom? Okay. All right. Well, Tom, thank you very much. Yeah.
All right. Thank you.
Yeah.